Hello, in this lecture we'll find out the area of the circle. In the drawing we have quadrilateral ABCD. Inside this quadrilateral we have this circle. In addition, we know that side AB equals to 2 units, side BC equals to 8 units, side DC also equals to 8 units. This angle DCB equals to 90 degrees, and this is angle ABC that is also equals to 90 degrees in its size. Our mission is to find out the area of this circle. So first of all we do a construction, that is to say we will extend side DA and side CB by a straight line until they touch each other. We define the touching point of the extended DA and extended CB, this point is M. So actually side BC is one side of quadrilateral ABCD, therefore it is absolutely a straight line. Then we extended the straight line CB by straight line, and the result is MC. So when you extend a straight line by straight line, the result must be a straight line. So therefore, line segment MC must be a straight line. So line segment MC. So if we focus on the upper side of the straight line MC at point B, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles from one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of CM at point B? We have this angle that is equal to 90 degrees, plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees. We focus on the right triangle ABM. On this right triangle ABM, we define angle AMB. This angle is theta. So in the right triangle ABM, we have this angle that is equal to theta. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Okay. Likewise, we'll focus on the big right triangle DCM. Inside this big right triangle DCM, we have this angle that is equal to 90 degrees, this angle equals to theta, therefore the missing angle here must be equal to 90 degrees minus theta. In the next step, we'll prove that the big right triangle MCD is similar to the small right triangle AMB. So I write it down. The big right triangle MDC is similar to the small right triangle AMB. So why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So I can write down that angle DCM in the big triangle, this angle, equals to this angle in the small triangle, that is angle ABM. Repeat again. Angle DCM in the big triangle equals to angle ABM in the small triangle. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta that belongs to both triangles, so I can write down that angle theta equals to itself. We can define angle theta, we can call to angle theta two different names. Angle theta, it is actually angle DMC. If we relate to it as it belongs to the big triangle, so angle DMC, that is angle theta, equals to angle AMB. If we relate to angle theta as it belongs to the small triangle, it will be defined as angle AMB. Repeat again. Angle theta is angle DMC. We can define angle theta also as angle AMB. So angle theta is a common angle that belongs to both triangles, therefore angle theta equals to itself. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So I can write down that this is angle MDC in the big triangle. It is equal to this angle, that is angle MAB in the small triangle. Repeat again. Angle MDC in the big triangle equals to angle MAB in the big triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually we proved that all the three angles in the big triangle MDC are correspondingly equal to all the three angles in the small triangle AMB. Therefore we proved actually that the big triangle MDC is similar, this is the sign of similar, to the small triangle AMB, according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all the three angles in one triangle are correspondingly equal to all the three angles in another triangle, then you actually proved that the two triangles are similar to each other according to angle similarity rule, exactly as we proved in our two triangles. Okay. And for the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. That MC in the big triangle over MB the small triangle equals to DC in the big triangle over AB in the small triangle. Repeat again. MC over MB equals to DC over AB. What is the length of MC? From the drawing it is very easy to see that MC equals to MB plus BC. So MC equals to MB plus BC, and BC is 8. BC is 8, therefore in total MC equals to MB plus 8. So we substitute MC here by MB plus 8 over MB is equal to DC over AB. DC is 8, AB is 2, so in total DC over AB it is 8 over 2. 8 over 2 is 4, so MB plus 8 over MB equals to 4. Here we multiply this equation by MB, and we get that MB plus 8 equals to 4MB. Here we subtract from this equation MB, and we get that it is plus 8 equals to 4MB minus MB, it is 3MB. 8 equals to 3MB. We divide this equation by 3, and finally we get that MB equals to 8 over 3 units. So we can write down here in the original drawing that MB, this I say that MB equals to 8 over 3 units. In the next step, we'll focus on the right triangle A and B, and we'll implement on this right triangle A and B the Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So actually, in our specific triangle A and B, the hypotenuse is AM, therefore the square of the hypotenuse is AM square, and it must be equal to AB square plus MB square. Repeat again, according to the Pythagoras theorem, the right triangle AB, AM square equals to AB square plus MB square. So AM square equals to AB square. AB is 2, so therefore AB square is 2 squared, it is 4, plus MB square. We just right now found out that MB equals to 8 over 3, therefore MB square it is equal to 8 over 3 square. So AM squared equals to 4 plus 8 over 3 squared equals to 8 squared, that is 64, over 3 squared, that is 9. Okay, so in the next step we will multiply 4 by 9 and then we divide it by 9 in order to have a common factor of 64 over 9, and we get that AM squared equals to 4 times 9 is 36, so we have the numerator of 36 plus 64 over 9. 36 plus 64, it is 100, so it is 100 over 9. Here we take the root out of this equation and finally we get that AM equals to the square root of 100 is 10 and the square root of 9 is 3. So if we found that AM equals to 8 over 3. Well, don't go in your volume here. That's AM. The hypotenuse AM equals to 8 over 3 units. So, in the next step, I present to you a new rule and we implement the new rule in our drawing. So, according to the new rule, rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. Here we have tangent AB that is tangent to this circle at point M. Point M is the point of tendency. And we have the radius OM that is drawn to the point of tendency. And whenever you have a radius that is drawn to the point of tendency, like in this drawing, then tangent AB will be perpendicular to the radius MO. So if AB is perpendicular to MO, it means that this angle equals 90 degrees and this angle equals 90 degrees. 90 degrees according to this rule, rule number 1. So you actually can implement rule number 1 in our drawing. First of all, we'll define the center of this circle as O. We define the touching point of tangent AB with this circle as M. We join points. So point M is the point of tendency of tangent AB with this circle. We join points O and M together by a straight line. Point O is the center of the circle, point M is the point of the circle itself. This is exactly the definition of a radius. So OM is the radius of the circle that we define as X. Point M is also the point of tendency of tangent AB with the circle. So the radius OM is drawn to point M, that is the point of tendency. Therefore, according to rule number 1, tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees in its size. This angle is also equal to 90 degrees. Okay. we define the point of tendency of tangent BC with this circle Sn, and then we join points O and N together by straight line. ON is the radius of the circle that is equal to x according to our definition. Again, we have the radius ON that is drawn to the point of tendency, that is associated drawn to point N, that is the point of tendency of tangent BC with this circle. Whenever you have a radius that is drawn to the point of tendency, like here, then tangent BC will be perpendicular to NO, to the radius NO. So if BC is perpendicular to NO, according to number 1, it means that this angle will be equal to 90 degrees. And this angle will be also equal to 90 degrees. So inside quadrilateral OMBN, we have 1, 2 right angles. The sum of right angles is 90 times 3 is 270 degrees, plus the missing angle here. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. In order to complete the sum of the angles with quadrilateral to 360 degrees, here the missing angle must be equal to 90 degrees. The next step we'll do a construction. That is to say, we'll draw perpendicular on BC in such a way that it will be also tangent to the circle. So this angle equals to 90 degrees, and this angle equals to 90 degrees. According to our construction, we define the touching point of the perpendicular, and BC SG here will extend the perpendicular until it touches side DM. We define the touching point of the extended perpendicular and side MD is T. We define the point of tendency of the perpendicular in this circle as H. Point H is the point of tendency of tangent TG with this circle. We join points O and N together by straight line. OH, this time second OH is the radius of the circle that is equal to x. Again, we have the radius OH that is drawn to point H, that is the point of tendency. Therefore, whenever you have a radius that is drawn to the point of tendency, then tangent TG will be perpendicular to the radius HO. So if TG perpendicular to HO, again, this angle equals to 90 degrees, and this angle equals to 90 degrees according to rule number 1. So inside quadrilateral OHNG, we have 1, 2, 3 angles. Therefore, the fourth angle must be equal to 90 degrees according to the rule that I have already mentioned, that the sum of the angles in any quadrilateral is equal to 360 degrees. So here we have line segment MH that consists the two radii of the circle X and X. And the size of angle MOH, the size of this angle MOH, it is equal to 90 plus 90 is 180 degrees. Any angle that is equal to 180 degrees must be a straight line. That is to say, MOH is a straight line. Angle MOH is a straight line. If MOH is a straight line, then MH is a straight line. So we found out that MH is a straight line, but MH touches the circle at points H and M, and therefore MH is a chord. MH is a chord that passes through point O, that is the center of the circle. Any chord that passes through the center of the circle must be the diameter of the circle. Therefore, MH is the diameter of the circle. So I write it down. We found out that line segment MH is the diameter of the circle. In the next step, we'll focus on quadrilateral MHGB. This quadrilateral will have 1, 2, 3, 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will relate to quadrilateral MHGB as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, MH equals to BG. Okay, I write it down that MH equals to BG according to the rule that the opposite sides of rectangle MH BG must be equal to each other. And from this equation, BG equals to MH equals to the diameter, we derive that BG is also the diameter of the circle. So this line segment BG is the diameter of the circle. And we also know that the diameter of any circle is twice as long as the radius. But the radius of this circle is defined as x, therefore the diameter must be equal to 2x. So BG equals to 2x in its length. You can write down here that this line segment BG is equal to 2x in its length. Okay, so in the next step, we'll focus on the right triangle MTG. The right triangle MTG, this angle equals 90 degrees, this angle equals to theta, therefore the missing angle here must be equal to 90 degrees minus theta, as I already explained before. In the next step, we'll prove that the big right triangle MTG is similar to the small right triangle AMB. So while those two right triangles are similar to each other, so I write it down, the big triangle TMG is similar to the small triangle AMB. So why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So we can write down that in the big triangle angle TGM is is equal to this angle in the small triangle that is actually angle ABM. So I'll repeat again. Angle TGM in the big triangle equals to angle ABM in the small triangle. They are both equal to 90 degrees. Therefore, they are equal to each other. In addition, this is angle theta, that is a common angle. It belongs to both triangles, so angle theta equals to itself. Angle theta, it is actually, you can call to angle theta as angle TMG. And you can call to the same angle theta as angle AMB. Repeat again. We call to angle theta two different terms, so this equation means that angle theta equals to itself, so it's a common angle that belongs to both triangles. And finally, we have those triangles that are both equal to 90 degrees minus theta, therefore they are equal to each other. So you can write down that angle GTM in the big triangle equals to angle MAB in the small triangle repeat again. Angle GTM in the big triangle equals to angle MAB in the small triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually prove that all the triangles in the big triangle TMG are correspondingly equal to all the triangles in the small triangle A and B. Therefore, we proved that the two triangles are similar to each other according to angle similarity rule. So we write it down. The big triangle TMG is similar to the small triangle A and B according to angle similarity rule. And from the fact that the two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that MG in the big triangle, MG in the big triangle over MB in the small triangle equals to TG in the big triangle over AB in the small triangle. Repeat again, you can conclude from the fact that the two right triangles are similar to each other that MG over MB equals to TG over AB. What is the length of MG? From the drawing it is very easy to see that MG equals to MB plus BG. That is to say MG equals to MB, that is 8 over 3 plus BG, that is 2x. So in total MG equals to 8 over 3 plus 2x. over MB is 8 over 3, and it is equal to TG is unknown, so we leave it as it is, over AB is 2, so we substitute AB by 2. So in conclusion, we found out that 8 over 3 plus 2x over 8 over 3 equals to TG over 2. Here we multiply 2x by 3 and then we divide it by 3 in order to have a common factor with 8 over 3. We do it now and we get that 8 over 2x times 3 is 6x over 3 divided by 8 over 3. It is equal to TG over 2. So here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. What is left from this equation after we cancel 3? On this side of the equation we have 8 plus 6x over 8 equals to TG over 2. So here we both multiply this equation and we get that 2 times 8 plus 6x equals to 8 TG. We divide this equation by 2 and finally we get that 8 plus 6x equals to 8 over 2 is 4, so it is 4 TG. Here we divide this equation by 4 and finally we get that TG equals to 8 over 4 is 2 and 6x over 4 is 1.5x. In conclusion, we found out that TG equals to 2 plus 1.5x. Write down here. This line segment TG equals to 2 plus 1.5x. From the fact that the big triangle MTG is similar to the small triangle AMB, we can derive from it that a relationship exists between their sides. We conclude that MB, the big triangle, is actually MG. MG in the big triangle over MB the small triangle equals to TM in the big triangle over AM in the small triangle. Again, MG over MB equals to TM over AM. I've already explained to you that MG is 8 over 3 plus 2x, over MB. MB is 8 over 3. And is equal to so it is TG, it is equal to TM, the hypotenuse of the right triangle TMP over AM. So TM, from the drawing it is very easy to see. The TM is TA plus AM. That is to say, TM is TA plus AM, that is 10 over 3. So in total, TM equals to TA plus 8 over 3. Over AM, AM is 8 over 3. Here we multiply 2x by 3 and then we divide it by 3 in order to overcome a factor of 8 over 3. And here also we multiply TA by 3 and then we divide it by 3 in order to overcome a factor of 10 over 3. So we have here 8 plus 2x times 3 is 6x over 3 over 8 over 3. So here we multiply TA by 3, so it is 3TA plus 10 over 3 or 10 over 3. So in conclusion, we found out that eight plus 6 or 6x over 3 over 8 over 3 equals to 3TA plus 10 over 3 over 10 over 3. So here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. Here also we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. And we left with only 8 plus 6x over 8, that is equal to 3TA plus 10 over 8. Here we first multiply this equation and we get that 10 times 8 plus 6x equals to 8 times 3TA plus 10. Here we open the brackets on both sides of this equation and we get that 8 times 10 is 80 plus 8 times 6x is 60x, that is equal to 8 times 3TA is 24TA plus 8 times 10 is 80. So here we have 80 on both sides of the equation, so 80 will get cancelled. And finally, what is left from this equation? We have here 60x, it is equal to 24 TA. Here we divide this equation by 24 and finally we get that TA equals to 60x over 24 is 2.5x. So finally we found out that TA equals to 2.5x. You can write down here. Sine TA or line segment TA, this line segment TA equals to 2.5x in its length. In the next step, I'll copy quadrilateral ATBG in a new page. Okay, this is quadrilateral ATBG that I call it from the original drawing. This quadrilateral ATBG blocks this circle. So I copy this circle in our new drawing. Here. The circle and the quadrilateral touch each other at 4 points. That is to say they are tangent to each other at 4 points. The first point is here, that I will define as M. The second point is here, that I will define as N. The second point is here, that I will define as N. And finally, the last point here is here, that I will define as S. Okay. So, in the next step, I will present to you a new rule number 2, and we implement the new rule in our drawing. According to rule number 2, the lengths of two tangents from common external point to a circle are equal. Point P is the common external point. From point P we draw two tangents to the circle, tangent PA and tangent PB. And according to this rule number 2, the lengths of those two tangents must be equal to each other. That is to say PA equals to PB. So whenever you draw from a common external point two tangents to any circle, the lengths of those two tangents must be equal to each other according to this rule number 2. So we can actually implement rule number 2 in our drawing. Here we'll focus on the common external point, point A. On the common external point, point A, here we have two tangents to this circle, tangent AM and tangent AN, and according to rule number 2, they must be equal to each other. That is to say, AM equals to AN. bn equals to an. So if an is a, then an must be also equal to a. Likewise, we focus on the common external point B. For point B, we have two tangents to the circle, tangent BN and tangent BL. According to number 2, they must be equal to each other. That is to say, BN equals to BL. So, if BN is B, then BL also must be equal to B. In the next step, we focus on the common external point G. For the common external point G, you have two tangents to the circle, tangent ds, and then tangent dl. And according to number 2, they must be equal to each other. That is to say, ds equals to gl. So, if gs is c, then gl must be also equal to c. Finally, we focus on the common external point T. On the common external point T, we have two tangents to the circle, tangent Tm and tangent Ts, and according to number 2, they must be equal to each other. So, Tm equals to Ts. So if Tm is D, then Ts must be also equal to D. Okay. In the next step, we will add side AT to side BG. So, what is the value of AT plus BG? From the drawing, it is very easy to see that AT equals to A plus D, so we substitute AT by A plus D. Plus BG. From the drawing, it is very easy to see that BG equals to B plus C, so we substitute BG by B plus C. In conclusion, we found out that AT plus BG equals to A plus D plus B plus C. We can change the orders of the variables in such a way that it is equal to A plus B plus C plus D. What is the value of AT plus BG? In the next step, we will add side AB to side TG. What is the value of AB? From drawing this value to see that AB, this side AB equals to A plus B plus TG. What is the value of TG? From the drawing this value to see that TG equals to C plus D. In the problem, found out that AB plus TG equals to A plus B plus C plus D. Exactly as the value of AT plus BG, it is also A plus B plus C plus D. And therefore, those two expressions must be equal to each other. So I can write down here that AT plus BG equals to AB plus TG. Here, AT equals to 2.5x, therefore we substitute AT by 2.5x. Plus BG, here BG equals to 2x, so we substitute BG by 2x. And it is equal to AB. AB is 2, so we substitute AB by 2 plus TG. Here TG equals to 2 plus 1.5x. Here we substitute TG by 2 plus 1.5x. Finally, we found out that 2.5x plus 2x equals to 2 plus 2 plus 1.5x. 2.5x plus 2x is 4.5x, and is equal to 2 plus 2 is 4 plus 1.5x. Here we subtract 1.5x from this equation, and we get that 4.5x minus 1.5x, that is 3x, that is equal to 4. Here we divide this equation by 3, and we get that x equals to 4 over 3. X is the radius of the circle. The area of any circle, here the square bracket is the sign for the area. The area of any circle equals to pi times the radius square. So if r is the radius, it is pi r square. Now a specific circle, the radius is equals to x, so it will be equal to pi x square. We just right now found out that x equals to 4 over 3, so it will be equal to pi times x is 4 over 3 square. Pi times 4 over 3 square equals to 4 squared, that is 16, over 3 squared, that is 9. Okay, so in conclusion, we found out that the area of this circle, it is equal to either 16 pi over 9 square units, or in terms of numbers, it is equal to 5.585 square units. Okay. Again, the area of the circle equals to either 16 pi or 9 square units, so in terms of numbers it is equal to 5.585 square units. So finish to answer the question. In the next step I'll summarize the lecture. In this lecture I found out the area of this circle. In the drawing we have quadrilateral ABCD. Inside this quadrilateral we have this circle. We know that the length of side AB is 2 units, side BC equals to side CD. They are both equal to 8 units in their lengths. This angle ABC equals to 90 degrees, and this angle DCB also equals to 90 degrees. Again, our mission is to find out the area of this circle. So first of all, we did a construction. That is to say, we extended side DA and side CB by a straight line until they touch each other. This is their touching point. We define the touching point, this touching point as M. Okay. Here we extended side CB, that is a straight line, by a straight line, and we got line segment CM. When you extend a straight line by a straight line, the result must be a straight line. So CM is a straight line. This line segment CM is a straight line. If you focus on the upper side of the straight line CM at point B, the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of CM at point B here? We have this angle that is equal to 90 degrees plus the missing angle. In total it must be equal to 180 degrees according to the rule that I mentioned. Therefore the missing angle here must be equal to 90 degrees. So this is the right triangle ABM. We define this angle as theta. This angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees it is equal to 180 degrees. That is the sum of the angles in any triangle. Then we focused on the big right triangle DMC. In this big right triangle DMC, this angle equals to theta. This angle equals to 90 degrees, therefore the missing angle there must be equal to 90 degrees minus theta. Then we proved that the big triangle DMC is similar to the small triangle ABM. Why those two triangles are similar to each other? First of all, those triangles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle that belongs to both triangles, so angle theta equals to itself. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually prove that all the three angles of triangle DCM are correspondingly equal to all the three angles of triangle ABM. Therefore we actually proved that the big triangle DCM is similar to the small triangle ABM according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all three angles of one triangle are correspondingly equal to all the three angles of another triangle, And you actually prove that the two triangles are similar to each other according to angle similarity rule. Exactly as we proved here in our two triangles. From the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. That MC in the big triangle over MB in the small triangle equals to DC in the big triangle over AB in the small triangle. I'll repeat again. MC over MB equals to DC over AB. MC, although it is very easy to see that MC equals to MB plus BC. That is to say, MC equals to MB plus BC, that is 8. So in total, MC equals to MB plus 8. So here, MC equals to MB plus 8 over MB. This is equal to DC. This is 8, AB is 2, so this over AB is 8 over 2. 8 over 2 is 4, so MB plus 8 over MB equals to 4. We multiply this equation by MB, and finally we found out that 4 times MB equals to MB plus 8. Here we subtracted MB from this equation, and found out that here 4 MB minus 3 MB is 3 MB, so 3 MB equals to 4 MB, 3 MB equals to 8. We divided this equation by 3 and finally found out that MB equals to 8 over 3 units. So here, this line segment MB equals to 8 over 3 units, then we implemented the Pythagoras theorem on this right triangle ABM. According to the Pythagoras theorem, the right triangle ABM, AM square equals to AB square plus BM square. Repeat again. In the right triangle ABM, AM square equals to AB square plus MB square. AM square equals to AB square. AB is 2, so AB square is 2 square, that is 4, plus MB square. MB is 8 over 4, 8 over 3, therefore MB square is 8 over 3 square. So AM square equals to 4, plus 8 over 3 square. 8 over 3 square equals to 8 square, that is 64, over 3 square, that is 9. So AM square equals to 4, plus 64 over 9. Then we multiplied 4 by 9, and then we divided by 9 in order to overcome a factor with 64 over 9. And we got that AM square equals to 4 times 9 is 36, plus 64 over 9. 36 plus 64, it is 100, so AM square equals to 100 over 9. We took out of this equation and found out that AM equals to the square root of 100 over 9, the square root of 100 is 10, and the square root of 9 is 3. So in conclusion, we found out that the length of the hypotenuse AM equals to, it is equal to 10 over 3 units. Then I presented to you rule number 1, and we implemented rule number 1 in our drawing. According to rule number 1, tangent to a circle is perpendicular to the radius drawn to its point of tendency. Here we have tangent AB that is tangent to this circle at point M, and we have the radius OM that is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. So if AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle equals to 90 degrees according to this rule, rule number 1. We can implement rule number 1 in our drawing. First of all, we define the center of this circle as O. AB is tangent to the circle at point M. Point M is the point of tendency. we join points O and M together by a straight line. Point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius that we define as X. We have the radius OM that is drawn to point M, that is the point of tendency. Therefore, tangent AB will be perpendicular to the radius MO according to rule number 1. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. BC is tangent to the circle point N. We join points O and N together by a straight line. ON is the radius that we defined as X. The radius ON, it is drawn to point N, that is the point of tendency. Therefore, tangent BC will be perpendicular to the radius NO. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. In quadrilateral OMBN, we have 1, 2, 3 right angles. 90 times 3 is 270 degrees, plus the missing angle. In total, it must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. Okay, then we did the construction. On BC, we draw perpendicular in such a way that it will be also tangent to the circle. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. GH is tangent to the circle at point H. We join points H and O together. OH is the radius of the circle, that is X. The radius OH is drawn to point H, that is the point of tendency, therefore tangent HB must be perpendicular to the radius HO according to rule number 1. This angle, that is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. So in quadrilateral HONG, we have 1, 2, 3 right angles, therefore the fourth angle must be equal to 90 degrees according to what I already explained in this quadrilateral. So we have line segment MH here, angle MOH, this angle equals to 90 degrees plus 90 degrees, it is 180 degrees. Any angle that is equal to 180 degrees must be a straight line. Therefore, angle MOH is a straight line. If MOH is a straight line, then MH is also a straight line. So, but MH touches the circle at point M and H. Therefore, MH is a chord that passes for point O, that is the center of the circle. Any chord that passes for the center of the circle must be the diameter of the circle. Therefore, MH is the diameter of the circle. Here, MH is the diameter of the circle. And we focus on the quadrilateral MH GB. Inside this quadrilateral, we have 1, 2, 3, 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will relate to quadrilateral MHBG is a rectangle. The opposite sides of a rectangle are equal to each other. That is to say, MH equals to BG. It again, in rectangle MHBG, MH equals to BG. And from this equation, BG equals to MH equals to the diameter, we derive that BG is also the diameter. In this instance, BG is the diameter. The diameter of any circle is twice as long as the radius, and the radius is x, therefore the diameter BG must be equal to 2x. Here, the diameter BG equals to 2x. Okay, then we extended the perpendicular DH until it touches the circle, until it touches the side DM at point T. In this way we created triangle TGM. In triangle TGM, the big triangle TGM, this angle equals to 90 degrees, this angle equals to theta, therefore the missing angle here must be equal to 90 degrees minus theta. Then we proved that the big triangle TMG is similar to the small triangle ABM. Why those two triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles. Therefore, we can say that angle theta equals to itself, and finally those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually proved that the big triangle T, all the three angles in the big triangle TGM are correspondingly equal to all the angles of the small right triangle ABM, therefore the two right triangles are similar to each other according to angle similarity rule. And for the fact that those two triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that MG in the big triangle over MB in the small triangle equals to TG in the big triangle over AB in the small triangle. I'll repeat again. MG over MB equals to TG over AB. We already found out that MG, it is very easy to see that MG equals to 8 over 3 plus 2x. So we substitute MG by 8 over 3 plus 2x, and MB equals to 8 over 3. Okay. TG is unknown, and AB is 2. Okay. Here MG is 8 over 3 plus 2x, MB is 8 over 3, TG is unknown, and AB is 2. So we got this equation, and then we multiply 2x by 3, and then we divide it by 3 in order to have a common factor with 8 over 3. And we found out that 8 plus 2x times 3 is 6x over 3 over 8 over 3 equals to TG over 2. We have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. And finally we found out that 8 plus 6x over 8 equals to TG over 2. Repeat again. Eight plus 6x over 8 equals to TG over 2. We cross multiply this equation and found out that 2 times 8 plus 6x is equals to 8 times TG. We divided this equation by 2 and found out that 8 plus 6x equals to 8 over 2 is 4, so it is 4 TG. Then we divided this equation by 4 and found out finally that TG equals to 8 over 4 is 2, and 6x over 4 is 1.5x. So in total we found out that TG equals to 2 plus 1.5x. Repeat again, yeah. This time segment TG equals to 2 plus 1.5x in its length. Then, from the fact that the big triangle TGM is similar to the small triangle ABM, we will derive that addition relationship exists between their sides. We will derive that MG in the big triangle over MB in the small triangle equals to TM in the big triangle over AM in the small triangle. Repeat again. MG over MB equals to TM over AM. I've already explained to you that MG equals to 8 over 3 plus 2x. MB is 8 over 3. What is the length of TM? From the drawing it is very easy to see that TM equals to TA plus AM. That is to say TM equals to TA plus AM, that is 10 over 3. So in total TM equals to TA plus 8 over 3. Yeah. TM equals to TA plus 8 over 3. And yeah, AM is 10 over 3. Then we multiplied 2x by 3 and we divided by 3, and here we multiplied TA by 3 and we divided by 3. So here we have 8 plus 2x times 3 is 6x, so it is 8 plus 6x over 3 over 8 over 3. It again is 8 plus 6x over 3 over 8 over 3. Here we also multiplied TA by 3 and then we divided by 3 and found out that 3 times TA plus 10 over 3 over 10 over 3. Here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. Here also we have 3 in the numerator and 3 in the denominator, so 3 also will get cancelled. And we left only with 8 plus 6x over 8. In this side of the equation, it is equal to 3TA plus 10 over 10. Here we cross multiply this equation and finally found out that 10 times 8 plus 6x equals to 8 times 3TA plus 10. We opened the brackets on both sides of the equation and found out that 10 times 8 is 80 plus 10 times 6x is 60x. That is equal to 8 times 3TA is 24 3TA plus 8 times 10 is 80. We have 80 on both sides of the equation, so 80 will get cancelled and we left only with 60x, that is equal to 2048. Here 60x equals to 2048. We divided this equation by 24 and finally found out that TA equals to 68 over 24 is 2.5x. Yeah, this line segment TA equals to 2.5x in its length. Then I copied quadrilateral ATGB in a new page. Here. This is quadrilateral ATBG that I copied from the original drawing. This quadrilateral blocks this circle. So I copied this circle in a new drawing. The quadrilateral and the circle touch each other at four points. That is to say, they are tangent to each other at 4 points. The first point here is M, the second point is N, the third point is L, and the fourth point is S. Then I presented to you rule number 2, and we implemented rule number 2 in our drawing. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. We have the common external point P. From the common external point P, we draw two tangents to the circle, tangent PA and tangent PB. And whenever you draw from a common external point two tangents to a circle, then the lengths of the two tangents must be equal to each other. In this case, PA equals to PB. We implemented the new rule in our drawing. Here we have the common external point A. From the common external point A, we have tangent AM and tangent AN. And for rule number 2, they must be equal to each other. That is to say, AM equals to AN. AM equals to AN. So if AM is A, then AN must be also equal to A. Then we focus on the common external point B. From the common external point B, we have tangent BN and tangent BL. And according to rule number 2, they must be equal to each other. That is to say, BN equals to BL. So if BN is B, then BL must be also equal to B. Then focus on the common external point G. For the common external point G, we have tangent GL and tangent GS to the circle, and according to rule number 2, they must be equal to each other. That is to say, GL equals to GS. So if GL is a C, then GS must be also equal to C. And finally, we focus on the common external point T. On the common external point T, we have two tangents to this circle, tangent Tm and tangent Ts. And according to rule number 2, they must be equal to each other. That is to say, Tm equals to Ts. So if Tm is D, then Ts must be also equal to D. Okay. Then we added points AT. We add side AT to side BG in this quadrilateral AT BG. Again, AT plus BG. The length of AT is A plus B, and the length of BC is B plus C. Okay, so in total, AT plus BG equals to A plus D plus B plus C. We can change the order of the variables, and we can write down that A plus D plus B plus C equals to A plus B plus C plus D. Then we added side AB to side TG in this quadrilateral ATBG. AB equals to A plus B and TG equals to C plus D. So in total, AB plus TG equals to A plus B plus C plus D. I repeat again, AB plus TG in quadrilateral ABTG equals to A plus B plus C plus D. Exactly as the value of AT plus BG, it is also equals to A plus B plus C plus D. Therefore, the two expressions equals to A plus B plus C plus D. Therefore, they must be equal to each other. That is to say, AT plus BG equals to AB plus TG. Those two expressions must be equal to each other. So here, AT is 2.5x, so we substituted AT by 2.5x, plus BG is 2x, so we substituted BG by 2x, and it is equal to AB is 2, so we substituted AB by 2, plus TG is 2 plus 1.5x, so we substituted TG by 2 plus 1.5x, and finally we found out that 2.5x plus 2x equals to 2 plus 2 plus 1.5x. 2.5x plus 2x is 4.5x, and 2 plus 2 is 4 plus 1.5x. We subtracted 1.5x from this equation. 4.5x minus 1.5x is 3x, so 3x equals to 4. We divided this equation by 3 and finally found out that x, the radius of the circle, equals to 4 over 3 units. The area of any circle, the square brackets is the sign for the area, equals to pi times the radius square. If r is the radius, it is pi r square. In our specific circle, the radius is x, therefore the area of the circle will be equal to pi x squared. We just right now found out that x equals to 4 over 3, so we can substitute x by 4 over 3, we did it, and we got that pi x squared is pi times 4 over 3 squared. So it is pi times 4 over 3 squared. 4 over 3 squared equals to 4 squared, that is 16, over 3 squared, that is 9. So in conclusion, we found out that the area of our circle equals to either 16 pi over 9 square units, or in terms of numbers, the area of this circle equals to 5.585 square units. Okay, thank you very much.